Welcome guys to another lecture on Java. Today we're going to look at annotations. This is one of the mostly used concept in programming today, and it's very helpful. That's why I normally like to call today's developers the annotation generation, because we seem to depend on annotations mostly in our today's coding. And annotations were added in Java 5. Since then, they have changed the way we do programming today. So this is quite an important subject or concept in the Java language. So we are going to look at the following contents under the annotation. So there is a way of embedding supplementary information to our class, to our methods, to our file, and this is called an annotation, or you can also call it metadata. So you are adding additional information on something else. So we will see as we go on how you can achieve that with Java. So annotations consist solely of method declarations without any implementations, and they cannot extend anything. I mean, they do not have extend clause in their declaration, as you can see under this on this diagram more. When you say at interface more, you cannot have extend on it. Annotations implicitly extend annotation interface, and any declaration can have an annotation applied to it. Declarations, I mean class name on top of a class, on top of a method, or just on parameters or under enum types, Yeah, so the order of fields or members does not matter. So if you can see here where we are using this annotation, more, we say value equals to 9, str equals to Java. So we can swap this the order. We can put str first and put value, and we see that this annotation, we don't have anything. It doesn't have the retention type, which is by default class. It doesn't have the target, where can it be applied, which means it can apply it anywhere. If you don't put a target, it means you can apply it anywhere. We will see all those properties as we continue. So this is a way to define a basic annotation, as we saw. You use at keyword followed by interface, then the name of the annotation. Then we saw in our previous slide that the members of annotation actually are just methods without implementations, just method declarations, just like that. So there's what we call retention policy, and when you're using annotation, you can find that inside java.lang.annotation and .retention policy. So this is just an enum, and this enum determines how long annotations can be retained. They are used in conjunction with the retention metadata or meta annotation interface to specify how long annotations are to be retained. So if you say at retention, is also a metadata that comes with some retention policies. The no retention, as we saw in the previous annotation, actually defaults to class. So retention policy, we have three constants. We have source, we have class, we have runtime. If it's source, it means the retention is only applicable in source file, and annotation is discarded during compilation. You can normally use this when you want to enforce certain behavior or for some other compile time checks. Then we have another retention policy which is class, which means the annotation will pass the compilation, which means it will exist in the class file, but not retained by the runtime. Then we have retention policy called runtime, which means an annotation is available in the source, in the class file, and also at runtime. And this also implies if it's available at runtime, they can be read reflectively using reflection. So what is reflection? Reflection is a feature in the Java language, and it allows an executing Java program to examine or introspect upon itself and manipulate internal parts of the class or the program. For example, it's possible for a Java class to obtain the names of all its members and display them, even if they are not allowed to be seen. Or you can just say that via reflection you are allowed to do that. Obtaining annotation metadata at runtime, you use reflection, as we saw that you can read them if the annotation, the retention policy is set to runtime. Then reflection enables information about the class to be obtained at runtime. We already mentioned that. And all the members of the reflection, you will find them inside java.learn.reflect. So what you do in order to use a reflection, first get a class object that represents a class whose annotation is desired. You can call .getClass method. So the class object will actually give you this particular method. .get method, which will return method type, get field, which will require the field, get declared field, it will also give the field, get constructor, it will give you the constructor. So there are other methods that you can find. You can just open your class and then introspect it to see furthermore other methods inside that class object. Then there is what you call marker annotation, and this is a special annotation that contains no member at all, and you can use isAnnotationPresent to check if an annotation is a marker annotation. So this isAnnotationPresent is actually used in that sense and other cases. And what does it do? It will return true if an annotation for the specified type is present on this element, else false. And this method is designed primarily for convenience access to marker annotations. Then one member annotation. You can create an annotation that consists of one member. That means the declaration of one method. And when only one member exists, the name of the member is recommended to be value, so that you are able to use some shorthand notation when you are setting the values. We will see this when we do the demonstration. Then we have default values. Annotation members can have default values, in which case it is not required to specify the value for those listed with default values when you are using the annotation. We will also see this when we are actually doing the coding. Then we have built-in annotations. They are at the retention. We saw that it specifies how long an annotation has to live. So a documented, which is a Java doc, to document the annotation. We see a target, which actually is used to specify which element on which element the annotation can be applied. We have inherited, can all be used on another interface. Then we have an override. We are familiar with this one, which is used to override a method. Deprecated, which mentions that this particular method will be removed in future versions of Java. Then we have a functional interface, which actually means that the interface in question has only one abstract method. Then we have at suppress warnings, which you use to suppress compiler warnings. Then a target annotation. If no target is specified, an annotation can be applied to any declaration. So these are the target values that you can specify. You see annotation type, a constructor field, local variable, method, module, package, parameter, type parameter, type use. Annotation type. So annotations could also be used on declarations. However, today they can be used almost anywhere. E.g., you can apply an annotation on a return type, or on a return of the value. And why is this important? This is important because it allows for further additional checks to prevent some errors. So if you want to specify where an annotation can be applied, you inside a target you can use that element type, and then you specify the type use. Is it on the type, on a field, on a method, parameter, etc. These constants are used in target meta annotation to specify where it is legal to write annotations of a given type. Then we also have what we call repeating annotation. There are some situations where you want to apply the same annotation to a declaration or type use, and repeating annotations were only enabled in JDK 8. And to enable that, you will have to enable an annotation with at repeatable. So as you can see on the image here, we have a schedule applied 2 times on a method do periodic cleanup. The first annotation says day of the month, last, day of the week, Friday, hour 23. So that means cleanup will be done last day of the month, and that day must be Friday, and it should be done at 11 in the p.m. So what is the step to create a repeatable annotation? The first is declare repeatable annotation type. As we see here, schedule is a repeatable, and the annotation type must be marked with the at repeatable meta annotation. The following example defines a custom at schedule repeatable annotation type. You see that it's at interface schedule and it's a repeatable. So this at schedule, we will see that it's a container which is required. So the value of the at repeatable meta annotation in the parenthesis is the type of the container annotation that the Java compiler generates to store repeating annotations. In this example, the containing annotation type is schedules. So repeating at schedule annotation is stored in an at schedules annotation. So now applying the same annotation to a declaration without first declaring it to be repeatable results in a compile term error. The second step, you declare a containing annotation type, and the containing annotation type must be the repeatable annotation type. The declaration for the schedules containing annotation type is as follows. So you just say at annotation schedules, then you declare the value and is of array of the repeatable annotation. Guys, that is all I wanted to say about repeatable annotation. Then we are going to do some coding.